Hey everyone, today we're going to discuss about graphing logarithmic functions. So, a logarithmic function is a function which follows the form f of x is equal to log of x to the base b, where b is any positive number not equal to 1. We can see here on our screen right now that this is an example of a graph of a logarithmic function. This is f of x is equal to log of x to the base 2. Now, one thing that we have to remember about logarithmic functions is that it is an inverse of an exponential function. You can see here that we have another graph. This is an exponential function, g of x is equal to 2 raised to x. And checking it with the logarithmic functions, it is the inverse. It is reflected across the line y equals x, as you may have remembered in our discussion during inverse function. So whenever we graph a logarithmic function, we just use the inverse of its equivalent exponential function. So let's have some of the properties of the graph of a logarithmic function. Number 1, we have the x-intercept is 1. There is no y-intercept. So let's look at the graph here. Let's delete this graph. We're not going to need it anymore. So let's look at this graph. The x-intercept is 1, as we can see here. This is the x-intercept. It's at 1. And there are no y-intercept. In fact, the graph will not intersect at the y-intercept at all. This y-axis is a vertical asymptote, which leads us to the second property. The y-axis is a vertical asymptote and there are no horizontal asymptote. It is opposite with an exponential function where there is no vertical asymptote and the x-axis is horizontal asymptote. In the logarithmic function, the y-axis is the vertical asymptote and there are no horizontal asymptote. Number 3, if b is greater than 1, then the function is increasing. If b is in between 0 and 1, the function is decreasing. In this case, this graph is logarithm of x to the base 2. So we can see here that it is increasing. But if the graph is in between 0 and 1, it is decreasing. The graph should look like this. I will graph h of x is equal to logarithm of x to the base 0.5. So this is the graph of logarithm of x to the base 0.5. It is decreasing. And lastly, the graph is smooth and continuous. So it is a smooth curve. So whenever we graph it, make sure that it is a smooth curve. Okay, let's try to graph f of x is equal to 3 plus logarithm of x to the base 2. So one thing that we have to remember is that the logarithmic function is the inverse of an exponential function. So what we can do here is we can rewrite this one as an exponential function and get its inverse. So that's just basically it. So we change the f of x as y. So y is equal to 3 plus logarithm of x to the base 2. What we're going to do here is we're going to rewrite this logarithmic function into an exponential function. Let's transpose 3 to the other side, so this becomes y minus 3 is equal to logarithm of x to the base 2. Since 2 is our base, we'll have 2 raised to y minus 3. Y minus 3 is our exponent. It's equal to x. So we now have the expression as an exponential function. So let's write a table of values. But we're going to do this inversely, since remember we've said that the exponential function is the inverse of a logarithmic function and vice versa. So what we're going to do is we're going to assign values for y instead of x, since it is an inverse. So we will get to decide what will be the values of y. Let's look at this one. 2 raised to y minus 3 equals x. Since the value of h here, remember in our exponential function, we have the h and the k. Since h here is negative 3, the middle part of our table of values would be its opposite sign. So y would be equal to 3. And to the left of 3 is 2, and 1. To the right is 4 and 5. So let's solve for the values of x's given these values of y. If y is 1, 1 minus 3 is negative 2. 2 raised to negative 2 is 1/4. Please practice your fractions, and let's remember that we've done this already in our exponential functions. If y is 2, 2 minus 3 is negative 1. 2 raised to negative 1 is 1/2. 3 for y, 3 minus 3, 0. 2 raised to 0, 1. 4 for y, 4 minus 3, 1. 2 raised to 1, 2. And 5 for y, 5 minus 3, that's 2. 2 squared is 4. So this is our table of values. As you may have noticed, graphing logarithmic functions is similar with graphing exponential functions. It's just that we get to assign values for y instead, since it is an inverse function. So let's graph. For x is 4, y is 5. X is 4, y is 5. Okay? If x is 2, then y is 4. So we're plotting the points now. If x is 1, y is 3. So right here. Now for the next values of x would be in fractions, so we'll have to make an estimate. If x is 1/2, y is 2. 1/2 somewhere here, y is 2. And if x is 1/4, y is 1. So somewhere here. So these are the set of points that we're going to have, and we are going to trace them out and graph them. So the graph will be something like this. This is the graph of f of x is equal to 3 plus logarithm of x to the base 2. As you can see here, it matched all the points that we had. So that's how we go around in graphing logarithmic functions. We just graph the inverse of its equivalent exponential functions. So that's everything about graphing. For our next video, we will now proceed with the mathematical of investment. So I hope you guys learned a lot today. Thank you guys for watching, and see you guys in the next video.